So we're now going to start talking about generics. So what are generics in Java and why would we want to actually use them? Now actually, as you'll see in a minute, we've already used generics so far in the course and they actually are incredibly useful. So just as we can create methods that take arguments in Java and we can replace the parameters that we declare for the method, generics allow us to create classes, interfaces and methods that take types as parameters called, unsurprisingly, type parameters. So different to other parameters, we're talking about type parameters. So you've seen in previous videos when we created array lists and also linked lists, this in use, but just to show how useful they are, we're going to start with an array list example that doesn't use generics. So we're going to create an array list populated with integers and a method that prints the contents of the array list doubled. So let's go through and write that code. It's a good idea to see that first before we actually go ahead and use generics. So I'm going to type array list items equals new array list, and we'll add some items. Items.add 1. Let's add another 4. So 2, 3, 4, 5. So that's actually adding an integer to the array list, and it's using auto boxing automatically, which we've done before in the course. It's converting the primitive type that we've typed in there into an integer. And what we're going to do then is call a method called print doubled. We're going to pass the parameter, which is our array list items, and that function we're going to write now, and its purpose is just to double the contents. So I'm going to type private static void print doubled, and it's going to be an array list n, and we'll put for object I n, and we're going to print integer, casting it as an integer I times 2. So just before we discuss that, we'll actually run it to make sure that it actually works. And you can see we've got the numbers 1, 2, 3, 4, 5, and we're actually doubling them, multiplying the current value by 2, so getting 2, 4, 6, 8, 10. So that's actually worked. So we get the expected output. But note, however, we actually used object here because we didn't actually specify what the object was above, and we also had to cast it as an integer. So if I actually got rid of the cast here, we'd actually get an error. And the error was that it cannot be applied to objects. So we have to sort of tell Java what type of object is actually in that array list. So I'll put that back so that the code doesn't break. But technically, the array list, as we've created it, can actually contain anything, any type of object, not just an integer as we've actually done here. So that's actually more than a minor inconvenience because it also completely breaks the compiler's type checking. And just to see the impact of how this will affect us, if I try and add something here, like items.add, and add my name there. Now that's quite valid, and there's no indication that we've actually got a problem with our code. There's no red indications, red underlining our code. As far as Java is concerned, this is valid, and it actually is valid. But the problem is when we run it, we actually get an exception. So what's actually happening is with the object, which was a string, Tim in this case, trying to be converted to an integer, and it cannot be actually converted. You can see that java.lang.string cannot be cast to java.lang.integer. So in other words, we actually got an error because I tried to add a different type of data to the array list. The real problem wasn't so much that it crashed, although that's bad enough, but the real problem is that it's not actually showing up until runtime. So in other words, the program compiles fine. I can come up here and build and rebuild the project. And as far as Java is concerned, there are literally no problems. We've got a couple of warnings over here, potential warnings. Uncheck call to add E, it's a member of raw type array list, which is IntelliJ's way of sort of saying that maybe you should be doing this a different way. But the point is we don't actually get any errors as such. So if you actually see these errors in more detail, we can come up to the view menu, click Tools window, and actually select messages. So if we click on that, and we could do Command 0, and you can probably see what the equivalent keystroke is on your operating system. So click on that. You can see it's Alt 0 for Windows Linux, and we can actually see those warnings in more detail. We can actually see that main.java uses unchecked or unsafe operations, and that's Java's way of actually saying that there's actually a problem with our code. And again, just a confirmation that if we actually highlight this over here, IntelliJ is also sort of saying, okay, hang on, what are you doing here? So basically the Java compiler, and obviously IntelliJ by default, knows how to provide these warnings because they're actually looking at your code and they know that array list is a generic type, but we're using it without specifying a type parameter. In other words, using it without generics. So in other words, what we haven't done is sort of said with our array list what type of objects we're going to be storing in the array list. So the array list as we've used it here is a raw type. Now, prior to Java 1.5, this was the only way to code. There was no generics. And when Java 1.5 came out, they actually introduced the generics, which we're about to talk about. And they actually left this old way of doing things in purely for backwards compatibility with code that's written for previous versions. So, in other words, if they didn't do that, that old code would no longer run anymore. So the old code continues to run, but when you're writing new code, you should almost never use these raw types anymore. And you can see why, because obviously in this instance, we're able to crash it quite easily by making a simple little change there. And you might look at that and think, well, hang on, I know that there's integers and I'm never going to actually add a string there. But thinking ahead, down the track when your programs start getting a lot more complex, it can be a lot harder to track these types of bugs. This one's quite easy because it's only a few lines of code. It's certainly not recommended to use these raw types, and because type safety is so easy to implement these days in the current versions of Java, I highly recommend you actually do that. So when we actually provide a type parameter to a generic type, this is called a parameterized type. So we actually specify the type using angle brackets, and I know you've seen this before in earlier videos. So what we're going to do now is we're going to specify an integer type when we declare the array list on line 8. And also in the parameter on print double on line 20. So if we come up here to line 8, we're going to actually change this. We put our angle brackets in. Integer. So we're actually saying now this is the type that we're actually going to be using in this array list. We're also going to come down here to line 20, to line 19 I should say, and put array list integer, like so. So we're now specifying this is the type of data that we're actually going to be saving in our array list. And you can see what's happened straight away, that there's still a couple of errors. And you can see this one here is actually an error. It's actually telling us now that you're trying to add a string to what we've defined as an array list of integers, and it's actually an error. It's not a warning anymore, it's actually an error. So it's actually not allowing us to do that. But the first warning, it's still saying it's an unchecked assignment. We're actually still trying to use Java. It's actually saying now java.lang.integer, but it's still, as far as it's concerned, an unchecked assignment. And if I press my control function F1, and you can see it's just giving us an example of that. So we can actually fix that, try and fix that by putting another assignment here. We can actually type integer as well there, and that actually does get rid of that warning. So it does actually pay to look at these warnings that actually come up, and where appropriate to actually remove the code that is actually causing the warning. So you see in this case now, by adding an integer twice, we've actually removed the warnings, and I can actually now get rid of this as well, because that's no longer relevant. And we've now got a tick in the top right hand corner, and that basically says as far as IntelliJ is concerned, there's no longer any errors in our code, and our code is good to go. And again, if I get rid of that get rid of that parameterized type, we actually do get some warnings again. We get a few warnings, one here and also one here as well. So do actually pay heed to those errors, the warnings, because they do actually make sense to check them to make sure your code's adhering to the standards and you're not actually basically writing bad Java code. So adding a type here is actually unnecessary, because Java's got enough information in the declaration to the left-hand side to actually include that. So it's really is to see whether you're happy with these warnings or not. You could quite happily, as I showed you, delete that, and that is still valid and the code will still work. You've just got some warnings. So generally speaking, I would recommend just to do whatever it takes to get rid of the warnings, and you know that you're actually doing things the right way as far as the Java's concerned. And just also a note here, if you're actually doing this is another way of doing it. You can actually just specify the angle brackets without a type. And we've actually got an error message, and that's probably because I haven't set my appropriate language level up. So I'm just going to go into my settings, file, project structure, and I've got this set to 6 instead of 8. So I'm going to set that to 8. You notice diamonds is set for version 7, but I'm going to set it to version 8 because that's what it should be for each project anyway. If I click OK to that, that error should actually go away. And so what that's saying there now, that's probably the best way of actually writing the code, because what that is saying is that the first declaration here on the left-hand side is all that it needs, and we don't actually have to type another one. And I think we'll actually get a warning now if we actually type this in here, because we actually set to 1.8. You can see we actually got a warning now. Explicit type argument can be replaced with the diamond, and that's what this is. The two a less than and a greater than sign together is referred to as a diamond. So that using the version 1.8, and again I did that with file, project structure. It's making sure project language level was set to 1.8. Because I've got that set to 1.8, we've actually got a tick across the board. So that's actually the correct way to actually use it to make sure you haven't got any warnings. But if you were using an older level of source code, as you saw I had 1.6 in use, then you will actually have to specify the actual parameter there. And again, using that without a parameter in the middle is called a diamond. So now we haven't got any errors and there's no warnings left. And I've actually removed this because, of course, before without removing that, we've actually got one error. And of course, the error again was trying to add a string to an integer object, to an array list of integers. So I'm going to comment that out to get rid of that error. So we've now got no warnings and no errors. We've got the green tick in the top right hand corner, and that's exactly what we wanted. So by telling ArrayList what type of objects we wanted it to hold, the program now fails to compile when we try to add the value item 10. So I have to comment that out in order for the code to even be able to work. Now incidentally, coming down here looking at the loop, we can actually get rid of this cast now. We don't need that in there anymore. And we can change this. We can either set that to be an integer, or we can actually even go back and set that to an int. And Java is actually handling that for us automatically. Obviously, we don't need the object now because we know what type of data it actually is. And Java is smart enough to figure out that, okay, you're using an array list of integers here. Therefore, I know how to convert it back to an int, and it's doing that automatically with the auto boxing and unboxing that we've talked about in previous videos. And if we actually run this code, we should find that it actually works. And you can see we now get the same result. So that's the introduction to generics. In the next video, what I'm going to do is take it to the next level, and we're going to actually look at creating our own generic classes. So I'll see you in that video. So this is part 2 of generics for Java. And just before we actually start getting onto the code, I just want to go through a couple of brief points that the reason we're actually using generics. So it's commonly understood in programming terms that the earlier bug is spotted in the code, the easier and ultimately cheaper it is to fix. And that's because there's less resources and less manpower invested to actually fix that error. So if a bug appears in production code, production here means that code that has been released to the Google Store, or it's commercially available, or it's not test code anymore. It has to be fixed. There's no doubts about it that for most bugs, so some minor bugs that perhaps you wouldn't need to fix, but ultimately, if it's in production mode, it must be fixed. And so what it's fixing it, the code itself must be then fully tested to ensure that the actual fix you made didn't in fact introduce another bug. And then of course, finally, the updated code containing the fix or fixes has to actually be redeployed and uploaded to the Google Store or whichever Android app store you're actually using. And so any system, so that's any other apps that rely on the program, they too have to be tested to ensure that the fix hasn't broken interoperability between the two systems. Now, if the bug itself is spotted in testing, the effort's actually reduced slightly, but there's still a requirement for any tests that previously passed to be performed again. And of course, if the bug is spotted at compile time, no one else actually notices except you, the programmer, and the fix has had very low impact on everyone else. So that's the reason why you want to get these errors fixed early in your code. You don't want to find all these surprises, bugs later in the process, because particularly with larger applications, and when you're involving other resources, other people, it starts costing a lot of money, if nothing else, in programmers' salaries and time to actually fix those errors. So basically what I'm getting at here is that it follows that anything we can do to pick up these bugs at compile time, when we're actually writing our code the first time, is well worth the effort to get right. So in the previous video, I showed you how generic types can be used and how they're actually very useful to ensure that we don't produce a program that compiles fine but actually gives us errors at runtime. And I used the example there of actually adding a string to what was an array list that we assumed only contained integers. So let's actually have a look at taking that to the next step, and that's actually creating our own generic classes. Now, what I'm going to use for this example is the concept of adding players to various types of sporting teams. So to begin, we need to actually create some basic classes. So let's start off creating the basic abstract class. We come down here as we've always done and create the new class. So I'm going to do a new class. It's going to be an abstract class called player. So I'm going to make that an abstract class player, and we're going to have a string which will be the player name. We're going to add a constructor which will be name, so we can actually create the object, and just a getter as well for the actual player name as well. Very basic class for our player. So what we're going to do now is we're going to create 3 types. We're going to create a baseball player for baseball, a football player as in Australian rules football, and a soccer player as in soccer, which is what in Australia we call football, if that makes sense. Football for UK people. So I know that sounds a bit confusing, but that's what we call them over here in Australia. So I'm going to create those classes. First one's going to be baseball. Baseball player, I'm going to call it. And the baseball player is going to extend from player. So we need to create a constructor to pass that through so the actual name is stored, because that field is actually in the player class. So there's our baseball player. Let's create the football player. So football player. That's also going to extends from player. And we also need to create the constructor for that, so it's happy with that as well. And lastly, let's create the soccer player class. So soccer player. And we need to extends from player. Then we also need to create the constructor like so. So that's our 3 classes. There's nothing generic about those at this stage. But what we're going to do now is create a team class, and in that team class, add the ability to actually add players. So let's go ahead and do that. Create a new Java class. We're going to call it team. Now we're not extending from anything else because this is a base class. So we're going to have a name, and then this is the name of the team as opposed to the name of the player. So private string name. And we're going to keep this simple. We're going to just track the played, number of games played, number won, number tied, and number lost. So I'm going to put int played equals 0, int won equals 0, int lost equals 0, and int tied equals 0. Now obviously in a real application, you'd have to deal with fixtures and those sorts of things. We're going to keep it pretty basic as they're just with a basic number of fields. So we're going to create an array list that's using generics for our player object. So we're going to type private array list, and it's going to be of type player. Remember, player is our abstract class that all the other 3 classes extend from. And we're going to call that members. So this is members of the team equals new array list. And I'm going to remove that by default. We're probably getting an error about the level. So I need to make sure I've set the correct level up. So you may not get that error, but if you do, go to project structure and make sure that the project language level is set to 1.8. So I'm going to click on OK. And you can see that error then disappeared when I did that. So we need a constructor now. Constructor is going to just have the name, team name, passed to it and saved. And we also want a getter for the team name as well. So we'll just use just that one, the getter for the name. Now we come to the part where we're actually going to add the player. So we're going to have an option to allow us to do that. So I'm going to type public boolean. And boolean will be whether we successfully added them or not. Add player. Player. So player is the abstract class definition, remember, that we can pass to this. We can put if members contains player. And we can put message player dot get name plus is already on the team, so we're not going to allow a duplicate or duplicates. And then we're going to return false in that case. Otherwise, we're going to do add it, so members dot add player, and we're going to put the player name again, player dot get name plus picked for team plus this dot name. This dot name is the actual team name, and we're going to return true in that case because we successfully added it. You can see that's now a method, add player, and we're accepting the parameter of player, which is actually going to enable us with one call to actually pass a baseball player, football player, or a soccer player. And we're able to do that because we're using an abstract class, and obviously we're using a generics here for the array list definition of type player. So continuing on, we also need a getter, and the getter is going to return the number of players on the team. So I'm going to put public int num players, and that's just going to return the size of the array list. So this dot members dot size, like so. Okay, so next we're going to actually create a method that actually gives us a result, what actually happened with the team, whether we won or lost. So I'm going to put public void match result, pass team opponent, int our score, int their score. Instead of actually having to pass whether we won or lost, we'll get the method within this team class to actually determine that. So we can put if our score is greater than their score, 1++, because we obviously won the game, else if our score is equal to their score, tied plus plus, else we obviously lost because that's the only other potential option. And then we increase the number of games played. And then, interestingly enough, we put if opponent is not equal to null, opponent dot match result, null, their score, our score. So we're doing it this way now, so we can actually also update the opponent score. And when we basically call this opponent match result again, we're passing null this time, so that this doesn't get executed again. So this way we're actually saving our results for our team, but we're also saving the results in the opponent's team as well, saving the results in their sort of object, their separate object. So that's the match results. And finally, we want a ranking. So we'll just come up with some sort of ranking system that's pretty simple. So let's do ranking, public int ranking, return. Let's just do our ranking to be number of games 1 multiplied by 2 plus tied. Now that's obviously just one way of doing it. There's thousands of different ways of rankings, and you could actually implement this dependent on the actual class itself. But we're just keeping it simple for now. So now that we've actually got the base code in place, we can actually start creating various types of teams and adding players. So let's go to the main method and start that. So we could start by putting football player Joe equals new football player Joe, and say baseball player Pat equals new baseball player Pat, and soccer player Beckham equals new soccer player Beckham, even though I think he's retired. Okay, in team, so let's try typing team Adelaide Crows. The team I follow equals new team Adelaide Crows. And we can put Adelaide Crows dot add player Joe, Adelaide Crows dot add player Pat, and Adelaide Crows dot add player Beckham. Now why Beckham would be playing for AFO, I don't know, but anyway, that's an aside. And we can print that out now just to make sure that the basic thing is working. Adelaide Crows dot num players. We should get the right result if we do that. So what I'm actually going to do is I'm going to stop the video here. In the next video, we'll actually tackle this problem. This is the problem of actually making sure that a particular team will only accept a player of the correct type. So in this case, if we actually specify a team, then we only allow the correct people who are part of that team, in other words, a football player in this scenario for the Adelaide Crows, to be accepted as part of that team. So we'll do that in the next video. Now continuing on from our generic class from the last video, so we actually started this code, we didn't actually run it, so I'll just run it now. Just to confirm that we've actually got the right number of players. We should get the answer 3 because we've actually added 3 there. And you can see we've got the answer 3. But it does actually bring up an interesting issue. There's an obvious problem which I started talking about, and that's that the first time, in this case, our baseball player, and that's Pat, the first time he actually runs onto the field and tries to hit the football with his bat, he's probably going to be red carded and sent off the field. So in other words, our team class is actually allowing us to add any kind of player to the team, and there's no actual check to see whether they're the correct type of player. Because obviously in the case of the Adelaide Crows, we've decided that that's a football team, so there should be some way of ensuring that only players who are football players can be added to that team. And likewise for a baseball player, only baseball players should be able to be added to a team with that baseball. And likewise for soccer. So we need some sort of mechanism to actually make sure that happens so that only the right types of players can be added to teams. Now there is a few solutions to this. One solution would be to create 3 different team classes. So in other words, a football team, a baseball team, and a soccer team, like 3 different classes, and ensure that they only accept the correct player type. But in that case, the code is going to be largely identical. So we're going to be duplicating code, and it's usually never an efficient way to code to actually duplicate code. So I don't recommend that. And of course, that's not to say we couldn't extend the team class to create 3 different team types within there. So sort of have private classes for each of those team types. But then if we did that, we need to implement functionality that's unique to each team type in that code as well. So the common code to do things like add a player, play a game, record a score, etc. would be in the base team class. But fortunately, Java's got generics, which we're talking about obviously in this section, and it enables us to really specify a type when we're creating our class. And this is exactly what we want here. So what we want to do is modify team to be a generic class. So let's go ahead and actually do that, and we'll see that working. So we're going to go to our team class. We're going to come up here. We're going to start making some changes to it. So at the moment, obviously, it's accepting a generic player there. This is in the array list, also in the add player method. So let's actually make some changes. First, we're going to modify the class declaration to include a type parameter. So to do that, we use the diamond as we did before, but we put a T in the middle, and that's to indicate there's going to be a type there. We also come down here to array list and we do a similar thing. So instead of player, we delete that and make that T as well. T was, and you can see it comes up, IntelliJ comes up and says it's a type parameter of com.timbercharco.team, which is correct. And the third area we want to change is our add player. So instead of allowing a player class, we're basically adding the type parameter again for add player. So again, we're changing the type so we can make this more generic and it's going to work for any type of player. And how this basically works is when we actually instantiate a class, the T will be replaced automatically by Java with the actual class we're using, with the real type, in other words, when we're actually instantiating the class. And that's why we've actually changed the add player and the array list as well. So all three are changed so that we can actually, we're able to actually do that sort of type checking. So notice that we're actually getting an error in add player. And the reason is that we've specified that its type is T, which is a parameterized type, as we've said before. And because this type's not known until we actually instantiate a class, in other words, at runtime, there's actually no way for Java to know that an object of type T in this case really does have a getName method. So the only sensible thing the compiler can do in this situation is to flag an error, which is actually showing on the screen. Now we can get around that for the moment. So what we're going to do is we're going to cast player, the player parameterized type, to make that a player type before attempting to invoke its getName method. So we're not going to change the parameter here. We're going to actually change it when we're actually referencing it. So we're just going to do this. We're going to cast that to player, because we know ultimately it is going to be a player object, like so. We need to actually put two brackets there for that to work. Player, and then put another bracket there, and that should fix that up. And likewise for this one, and I need to put the casted as well. Player, and one more bracket should fix it. And that fixes it as well. Now, it is a solution, but it's a pretty ugly cast in the sense that we're invoking a method on the cast object, and we need parentheses around the cast before we can use getName. But do not fear, it's only temporary. Very soon we can see, I'll actually show you how we can remove the need to do this. But this will get us out of trouble for now while we're working through our code. So getting back to our main method now, to our main class and then to our main method, you can see that there's actually no errors at the moment. But if we actually have a look at some of these warnings, we're getting an unchecked call to add player T as a member of raw type com.timbercharco.team. So I talked about raw types in the previous video and what they were and how to get around them, and you also saw why we shouldn't be using them. So with that said, the program is still going to run, but poor old Pat will still be given a red card. So in other words, we're not validating the type of player against a particular type of team. But we can actually fix that quite easily by specifying what type of team our football team variable should be. So team now has the ability to accept a type argument, as we've just changed in the team class. So all we have to do is provide it with one. So we're going to go back to our declaration for the Adelaide Crows. We're going to change that. So we're going to add the type argument to that. That's going to be football player. So once we've done that, we've still actually got an error here, unchecked assignment, because what we haven't done is we haven't added the diamond. So we need to add the diamond after the team. Now they're actually using it to the left in the declaration section. So I'm going to put the diamond in there now, and that now removes that error. So we've got a proper assignment of our generic class now. So we've actually indicated that we're going to be using the football player, and as a consequence of doing that, you can see now Joe was added. And the reason that Joe is valid and it's not being, the compiler is not telling us that there's a problem, is that he was assigned as a football player. But in here, the other two, Pat and Beckham, because they were baseball players and soccer players, they don't meet the criteria for this type now, and they're actually getting flagged as an error. So actually an error, not just a warning. It's telling us that we physically can't add those to this class anymore based on the definition. So in other words, this particular instance of team is now only going to accept football players, and the attempts to add Pat and Beckham are now showing errors. So let's give good old Pat a chance to shine. So what we're going to do is we're going to comment out these first, get rid of those, and let's actually add another class. We're going to call it team baseball player. We'll call it baseball team. I'll get rid of player team. We'll call it baseball team equals new team. Again, we need to add the diamonds if we're actually using that on the left hand side, which we are for our type assignment. And it's a type of team like Chicago Cubs, which is a baseball team in America for those who don't know. And we can now successfully do baseball team dot add player Pat. And that'll work quite nicely because again Pat is he's been defined up here as a baseball player. He's of type baseball player, and we've defined that as the team of being of type baseball player, so consequently he's able to be added without any problems. But with that said, there's still some problems here. And at the moment, the type parameter T in our team class can be supplied any type except primitive types such as int. So in other words, any object. So we're not doing any validation of that. So we could actually do something like, for example, team string broken team equals new team, and this won't work, which it won't work. And if we did something like broken team dot add player no one. Now string's a valid type, and as you can see there's no compilation errors. We're just getting a warning up here because Beckham's actually not in use at the moment. But the problem with this is going to be the cast when we actually go to run this. So if we actually run this code, we actually get an exception. And the exception has got to do with the fact that java.lang.string cannot be cast to com.timbercharcoal.player. And of course, if you remember, going back to our team class, we actually defined that in here. We actually added this ugly cast to get the .getName to work. So what we really need is some sort of way to validate the type of class actually when we're using it for this team. So in other words, we need the ability to restrict the type that can be provided for this T argument from the team class. Now the good thing about that is that Java also provides a mechanism for restricting the types that can be used as type arguments, and they actually call these bounded type parameters. By using those, you can provide them with an upper bound. So I'm going to explain these terms in more detail once we've seen them in action, but let's actually change the declaration of our team class first, and then we'll go through it. So at the moment we've got team, and then we've got the type in diamond, as you can see there, but we can actually change this to put extends player, noting that I'm actually typing it within the diamond. So T extends player now. And if we go back now to our main class, because we've done that, we're now actually getting an error here. And notice it's not a warning, it's actually an error to say java.lang.string is not within its bound. It should extend com.timbercharcoal.player. So that's our way of actually restricting the type of class that we can actually use for team. And just opening that up again. So basically what we've said is that we've told Java that the type parameter will accept for this class when using generics is going to be any type that extends from player or a subclass of player. So in other words, by typing it like this with this extends player, player is said to be the upper bound of T. And of course T, as I mentioned earlier, is a bounded type parameter. So if we attempt to use any class, in other words, that is not derived from player, we're going to get that error, which we're seeing here in main now. And as a consequence of that, because we've actually done that, the good news is we can go back to our code again, go back to team, and we can actually get rid of this cast. So we can actually remove that and go back to what it was before, which is just player.getName. So I'm going to do that, like so. And for the next one. And again, the reason we're able to do that is because of the bounded type parameter we've put up here. We've said that all valid upper bounds of T have to extend from player. So as a consequence, Java then knows that, okay, so in other words, Java now knows that the type T in add player extends from player. So it's going to have all its methods, including get name of player. So basically there's no longer an error and there's no need for you to actually add that cast anymore. So going back to our main method again. So let's actually change now this team here. We're at the moment the broken team to be a soccer team. So we can type soccer player, broken team equals new team. This won't work. And notice how it still is it's come up okay. We've defined a new team, and even though we haven't changed the name. But the important part here is this next declaration is broken team.add player, and we're passing the string. Java's also showing an error for that when we try to pass the string to the addPlayer method. And again, this is exactly what we want because we've defined the addPlayer method and the class to require us to use the player class or a subclass of player. And obviously string isn't that, and that's why we're actually seeing that error. So if we actually replace that string with our soccer player Beckham, we actually see that the error goes away and we've got a tick in the top right hand corner and no warnings either. So before going on to the challenge in the next video, I just want to discuss a few other points. Firstly, an argument passed for a type parameter can either be a class or an interface, so you can actually use interfaces as well. So although we use the player class in this example, this is going back to team, we've used the player class there. You could have declared team to accept an interface instead, and that's certainly valid to do that in Java. And the other thing to note is that interfaces themselves can also specify type parameters. So in other words, you can create instances of a class that implement an interface, and then you can ensure that the interface methods you implement act on a specific type of object or objects. And we've seen that in previous examples when we used the list string, for example. List was an interface that takes a generic type parameter, and the usage is the same as it is for a class. Now, we also used a single bound when we specify the team type parameter, so restricting teams to being created for objects that will inherit from the player class or a subclass of player only. Now, Java does allow multiple bounds, so you can have class T extends player and coach and manager, for example, to allow multiple instances of player, coach, or manager to be added to the team. But with that in mind, the normal inheritance implements rule still applies. So in other words, you can only extend from a single class, but multiple interfaces. So basically, if you want to do this with more than one class, you'll need to use interfaces for those other types as well. And the other thing to keep in mind is if you're specifying multiple bounds, then the class must be listed first. Otherwise, Java is going to raise an error when you try to actually compile it. So in other words, class first and then interfaces. And the way you do that, just briefly, we're not going to actually add the code there now, but you put something like and coach and manager for argument's sake. That would be the syntax you would actually use, but obviously you could only have one class, so these two here with this scenario would actually have to be interfaces. So I just want to confirm that is actually the syntax if you're wanting to use multiple bounds. So you put the player, in this case the class first, and then you'd actually put the interfaces after that if you wanted to do that. Obviously we're not doing that in this example, so I'm going to actually remove those. And obviously in the case of multiple types, you'd have to then include code to check what type of object you're dealing with before invoking its methods, because it wouldn't be just in this case, just the one class which was player, and there'd be a little bit more code to actually add to do that. And finally, soccer player and also football player are both subclasses of player, as we know. So obviously there is a relationship between them. So either can be used when calling a method that expects a player, for example. But the important thing here is to remember is that there's no relationship between something like this. So if we look at list manager, list soccer player, and list football player, and I'll just add those even though we're not going to do anything more with them. So there's basically no relationship in this case between those two, and the reason is because neither of them are a subtype of list player. They do have a common parent, but the common parent in this case is list. So I hope that makes sense. The bottom line is for a code, probably a lot of the time with generics, you'll probably be doing something like this where you'll only be extending or using one class and maybe an interface. But if you do need to use multiple bounds, you'll need to specify the ampersand and then obviously also the interfaces as well. And just one more thing we need to look at before we actually get to the challenge. So the team class has got fields to track how many games were won, tied or lost, but we haven't actually made use of them yet. So we did include a match result method. So let's make some calls on it now in main just to record the game results before we discuss the method more. So I'm just going to actually copy and paste some code here. Okay, I'm going to go back to main. I'm going to paste this code in, I should say, like so. And I'm going to change that to Adelaide Crows. Then I'm also going to do Adelaide Crows dot match result, and I'm going to type Fremantle 2-1 and Adelaide Crows dot match result baseball team 1-1. So if we actually run that, basically it does seem to be doing something, but we're not actually getting a lot of feedback from it. Now the match result method, if we go back to that and have a look, you can see that it does actually take a team object called opponent and two ints, which is our score and their score. And if our score is greater than their score, then we've won. So we've won is incremented, as you can see in this code here. Similarly, for tied and lost, we actually go through that process. If the scores are equal, tied, otherwise we indicate that it's lost. So that takes care of the team that match results called from, but the opponent also needs its fields updating, and that's why we've actually got this additional call here. So we do that by invoking the opponent's match result method as well. And this time, obviously, we're passing null for the opponent argument, and only we're invoking the opponent's match result method if opponent is not null. Otherwise, we would end up calling match result on the first team again, on and on and on again. We get into an infinite loop. So let's actually just print a little message here. So we'll put something like this, so we've got a bit more feedback. We'll add a variable called the message, string message, and let's set that up to be message equals beat. And for tied, we're going to add message equals, drew with, and lost. Message equals lost to, like so. And if opponent's not equal to null, we're actually going to print the result there. So we're going to put system out this.getName plus message plus opponent.getName, just so we've got that bit of output on the screen. And notice here that we're also only printing the message for the initial team, so we're doing that test for it's not equal to null. This makes sense, but because we're printing the name of the opponent, we get an error if we attempt to display the message outside of the check for opponent being null. So let's actually run this. And you can see we're getting some output now. And Drew, we've got a problem there with the way that I've typed in Drew. I need to put a space there. So I'll go back to there and run it again. And you can see it seems we're getting better feedback now. Hawthorn bet Fremantle, Hawthorn lost to Adelaide Crows, Adelaide Crows bet Fremantle, Adelaide Crows drew with Chicago Cubs. Now, can you spot a problem with match result yet? So the Adelaide Crows drew against the Chicago Cubs. What's going on there? But the Adelaide Crows played football, and of course Cubs played baseball, so that's rather an odd match result. So what we really want to do here is make sure that only the correct team type can be passed to the match result method as well, inside of any object of type team. So you can probably figure out how to do that now. So if we go back to our code again, and I'll just bring up the project window again and close down the run window, go back to team again. So we need to do something in here. You can probably figure out what we need to do to make sure that happens. We need to make use of its generic type, essentially, which we haven't been doing. So we're going to change that to use the generic type, which we've defined for this class. So now if we do that and go back to our class, back to our main method, I should say, we're now correctly getting this error, and it's saying that Adelaide Crows, well, we're supposed to only be using football players because that's how we've defined the Adelaide Crows up here, as to be a team football player. So Java is quite correctly indicating that's now a compile time error. So this video has gone on for long enough. So what I'm going to do is stop the video here. In the next video, we'll continue on and we'll just finish off a few other things to do with the way we've set this up, and then we'll move on to the challenge. So I'll see you in that next video. So just a few little things now to finish off in our generics code, and then we're going to actually move on to the challenge. So in the last video, I just showed you how to actually change the team match result method, like here, so we could actually use that type to actually confirm that only players of the appropriate type could, or only teams, I should say, of the appropriate type could call the method. And so consequently, in match result, when we're calling that from the Adelaide Crows, we can't actually pass a baseball team to it because we've defined Adelaide Crows to actually be a team of type football player. So therefore that baseball team isn't going to work. So I'm going to comment that out now. Now the team class includes a very simple ranking. I think I talked very briefly about that. And the ranking was just a very simple formula to calculate how this team is ranking in the league. And it's the number of games won multiplied by 2 plus the number of games tied. So pretty simple. So in a real, obviously, league, the ranking would also consider the number of games played and things like the goal difference and perhaps other things as well. And obviously, you're free to play with more complexity to the method if you're interested in doing these things for yourself and having a bit of a play around. But we're going to leave that as fairly simple for this exercise or for this example as we move forward. So let's actually go ahead now and actually print these rankings out. And that's actually quite simple to do. So we can just come in here and do some print out or print out some items. We can say rankings. Then we could do Adelaide Crows .getName plus colon, then plus Adelaide Crows .ranking. And likewise, we could do the same for Melbourne. Melbourne .getName plus colon space plus Melbourne .getRanking. Ranking. The next for Fremantle. Fremantle, these are all Australian rules football teams. GetName plus colon space plus Fremantle .ranking. And lastly, Hawthorn, who incidentally won the 2015 Premiership in Australia, plus space like so, and it'll be Hawthorn .ranking. So we can actually now run that. And we can actually see the Adelaide Crows have got 4 points. And if we have a look, we can sort of see why. Melbourne and Fremantle have got 0 points. because we haven't actually defined them as having any results, essentially. It's only Fremantle and Adelaide Crows have actually got some results in there, and Hawthorn have got 2 points. And you can see that's obviously from the various match results that we've actually entered. So that's all very well, but one thing we can't do is compare teams to see which would be the highest in the league table. And let's make a change to that. Let's actually make a change to our team class to implement something that's very useful in an interface called comparable. So I'm going to close down the run window and go back to the team class. We need to actually change the definition at the top. We've obviously got extending player. We need to then implements comparable, and we need to actually use the diamond again, so team T again, because obviously we want to make sure that we're still using the same generics like that. And obviously we're getting an error now because it's saying we must implement the abstract method compare to in order to actually fulfill this interface. And you can see there that there's literally only one thing to change, one method we need to do to actually fulfill the interface, and that's the compare to function. Now, because we only want to compare our teams to other teams, that's why we're actually using the team and the type. So it doesn't make sense to compare a football team to a baseball team. So that's why we're actually adding team and then the actual type in another set of diamonds. So the implements part looks complicated, but essentially what we're doing is we've created the ability to have generic types such as team football player. So all we're actually doing here is specifying a generic type as a parameter to the generic interface comparable. So team is the type in this case, and team football player, or team T's you've got here, is also a type. So comparable T in this case can accept either. So the compare to method that we're about to write, which is defined by the comparable interface that we're implementing up here, takes an object and returns a negative number if this is less than the object, 0 if they're equal, and a positive if this is greater than the object. So here what I'm talking about is less than means that we should sort earlier than. And as we want teams with higher rankings to sort higher up the list, we need to make our compare to return less if the ranking is greater than the opponent's. I hope that actually makes sense. Now, we've actually used the compare to method when we implemented our own linked list in a previous challenge, and many of the Java classes actually implement this interface, including the string and integer classes, and that's how these objects can be sorted as a result of doing that. But what we're doing is we're going to be writing our own code because, of course, we used the string compare to in the previous challenge. We're using the comparable interface, and we're going to be implementing the compare to method, which takes the parameter of team T, the type parameter to compare. So, and again, we're doing that so we don't try and compare football and baseball teams for argument's sake. So if we had just changed that so that was just literally team like this, compared to it could only take team as its parameter, then when we write the method compare to, it will only also be able to take team as its parameter, and we wouldn't have that ability to ensure that only the types of teams in this case that are appropriate can be passed to that method. So I'm going to leave that back in. So let's go ahead and actually write this compare to interface. I'm going to come down here under ranking, and I'm going to implement. Let's implement the compare to method. And you can see how it's automatically looked at their definition and has added a similar definition. So I'm going to change the default of 0 to team, because that's essentially what it is in this case. It's the team. And what we now need to do is go through and do this test like I've said. So the first test would be if this dot ranking, so this is the current object we're comparing, if it's greater than what's been passed to us, the team dot ranking. Remember, the higher the score, the better. Then we're going to return -1. So in other words, the current team, the one that we're actually in, this class in other words, or this instantiation of the class, if the team ranking for that is higher than the team that's been passed to this method, then it means that this is actually higher in essence, and we're going to return -1. That's the first one. Otherwise, we're going to put else if this dot ranking, if it's less than team dot ranking. So it's the other way around. We're going to return 1 because the opposite is true. The current object hasn't got more points, essentially. It's got less points, so we're going to return 1. And otherwise, we're going to return 0 because it obviously means that the rankings are actually the same. So that's all we need to do to implement that. And then we can go back to our main Java code and we can actually print that out. So we could do something like Adelaide Crows dot compare to, and let's just say Melbourne. And Melbourne, I believe, had 0 points. And then let's do the same for Hawthorn. So Adelaide Crows compare to Hawthorn. Let's just try those two and run them. So you can see in this case, Adelaide Crows has got 4 points And comparing to Melbourne, which has got 0 points, it returns -1 because we've got a higher ranking in this case than Melbourne. And likewise, compared to Hawthorn, we've also got a higher ranking. But if we actually wanted to do a test, let's actually compare Hawthorn to the Adelaide Crows. So we'll do it the other way around, just to confirm it's still working. We'll put, and Hawthorn compared to Adelaide Crows. We should get the opposite because we're now comparing Hawthorn to the Adelaide Crows from the other point of view. But also, let's do one that's the same. And we'll do Melbourne dot compare to Fremantle, with which both should return 0. So we should actually get 0 because they're both the same score. So we run those. So you can see the third example, now we've got Hawthorn compared to Adelaide. Adelaide's got more points, Hawthorn had less, so we returned 1 there. And in the last example, Melbourne.compare to Fremantle, they both actually had 0 points, so obviously the compare to returned 0. So that's actually working, which is good. Now, the reason we've implemented the comparable interface, other than to show you how to use it, because I think it's actually very useful, but it's also it's going to be to help you with the challenge to come in the next video. So if you've got a list of objects that implement comparable, now such as ArrayList team, for example, what you can do is you can quickly sort the list by using the static sort method of the collections class. I'm going to talk more about that and give you a little bit of a hint in the next video when we're actually going to go through the challenge. But essentially, if you've got an array list of teams, you can use this code, something like this. Some pseudocode would be, if you had something like an array list of teams, like so, you could do collections.sort teams. And that would be sorted. And the whole point about this is it'll actually be sorted using the compare to function that we actually wrote for the actual team itself. So in other words, this method would be actually automatically utilized by the actual code when we're actually doing the dot sort. And we're just getting an error there because we haven't actually initialized that. This is just purely to give you a bit of an overview of what it can do. Now that's obviously one way to do the sort, but you can obviously go back and refer to the sort method that we actually wrote for the arrays challenge as well. But you can see this is quite simple, actually using the built-in Java collections class. And we've got an entire section of that about collections in upcoming videos showing you how to use that. But this is just a simple way of doing that. But anyway, I'll talk more about that in the next video. I'm going to stop this one now. There's probably no point me starting the challenge in this video. What I'll do is I'll actually start the challenge in the next video, and we'll go through what's required and then actually type out the solution. So I'll see you in the next video. So it's time now for the generics challenge, and if you haven't actually looked at the previous videos, I do suggest you make sure you do that because you'll need to understand the concepts of generics. And what I've done is I've just added this little bit of code that I talked about right at the end of the previous video relating to how to go about actually sorting an array list of teams that we had in that example. And you'll need to know something like that when you're actually implementing this challenge. So let me go now and actually type out the generics challenge. Okay, so here is the challenge. So you'll need to create a generic class to implement a league table for a sport. Now the class should allow teams to be added to the list, and it should also store a list of teams that actually belong to the league. Now your class should have a method to print out the teams in order, and the team at the top of the league should be printed first. Now only teams of the same type should be added to any particular instance of the league class, and the program should actually fail to compile if an attempt is made to add an incompatible team. And this is relating to the concepts you've learnt in the last 4 videos in this generics section. So basically, if you've watched those videos, you'll have basically everything you need to be able to go ahead and actually do this challenge. All right, so when you're ready, pause the video and go away and see if you can actually figure out this challenge and come up with your own solution. When you're ready to come back and see what my implementation is, start the video again and I'll actually show you how to do it. So for now, pause the video and I'll be waiting here patiently for you to get back. Okay, so how did you get on? Did you figure out the solution? Hopefully you figured it out and have come up with a good alternative. And just a reminder, I know I've said this a few times, is there is no one answer that's perfect. So if you've got basically fulfilling the criteria that I've typed in here in the challenge, and your program does that, then that's great. You don't have to have typed the same code as me. So it's important to actually know that. Let's continue and start work on it. So firstly, we actually need a class. We're going to call it League. New class, call it League. And what we're going to do with the league, we're using generics, of course. So we're going to come over here, T, extends team. Now what I'll need to do, which I haven't yet, is I'll need to actually paste the team code in. I'm going to do that in a sec. And team code is obviously the code that was that we used previously. So I'm going to do public string name, private array list of the same type, league, equals new array list, like so. So I'm not sure if I've shown you how to do this before. I think I may have, but if you've got one IntelliJ project open, you can actually open up a second one. So we're going to leave this one open and do File, Open Recent. I'm going to go to the Generics Challenge, which was the last video prior to this one. I'll open that, and it should come up with an option here, and I'm going to select New Window. If I select this window, it's going to effectively close this current project and open another one. But I click on New Window, it's going to have both open at once. Then I can either come up here to Windows, probably the easiest way, and then choose Generics Challenge, which is the other project. So what I'm going to do is start copying some of these over. So I'm going to tab over. Now I'm going to actually use the Command tilde on a Mac, which actually switches, and you can see down there it's a new window project, Control Alt close bracket for Windows or Linux. And I can go to my Generics Challenge, and I can actually select, say, Player first. I can copy that, copy, tab back over, and paste. Now, obviously, depending on the number of classes, it may or may not be appropriate for you to actually do this amount of work. You know, it'd soon get tedious doing sort of a heap like this, but if there's only got a few classes, it can be a good way of doing it. It's a couple, and we'll add a few more. Football. We might see whether we can just get by with just football, and we'll come back and do some more if we need to. We'll paste that as well. So that we've done that, we'll just actually do a build. And I got the same error, source 1.6. I need to make sure I'm running source 1.8. And to fix that, that should actually make that problem go away. Okay, and I'll get rid of that window down the bottom. Okay, so we've got now the basic mechanism, so we can go back and continue with our leagues. I'm going to close down these other classes. We don't need them for a while. Go back to our league. So our league has now got an array list. We've got a type there, the parameter, so that we're using the team. And we're going to make sure that that's actually enforced. And just a note here, we don't actually need to have that in there. Remember, we just put the diamond by itself to actually get rid of any error, any warnings. Okay, we need to add a constructor. The constructor is only going to be the name of the league. We're going to add a function for add. It'll be public boolean add, which will be the team. And a simple if league dot contains team return false, so we don't want to accept any duplicates. Otherwise, we're going to do a league.add, add to the array list for team, and return true. So that is a mechanism now to allow us to actually save teams to the league. Then the other thing we want to do is actually go through and show the league table. We can do that quite simply with public void show league table. Now we use that collections dot sort league, and I'm going to accept the input. Now it's coming through automatically by IntelliJ. Now again, the reason that sort works is because within team we've actually written our compare to. We're obviously implements a comparable, but we've actually written our compare to, and this will be used automatically by the collections framework when we're sorting. So this, you can see that this is incredibly powerful to have our own compare to method, because it makes sorting quite trivial, and this is sort of like an automatic thing that will actually take that into account now, which is fantastic. So that's now sorted in this method, and then we can go through and we can put for type, the type, and T, colon league, go through each entry and do an output of a t.getName plus t.ranking, like so. So that's our show league table method. And again, we defined league to be a parameterized type that's bound by the team class. So in other words, a team or any subclasses would be allowed as the type argument when we create an instance of this league. And the parameterized type is used in the declaration of the array list up here as well. And that's obviously going to hold the league's teams. And also we're using that again in the add team. And then finally, when we're in the for loop in the show league table, that method sorts the array. So as I talked about, collections.sort, and you can see that I'm actually going through now and actually printing that out in the right order. And again, we've got the parameterized type as well in use there. So to actually go back to the main now, we could actually write a bit of code there now. So we could put something like league, team, football player, like so. So we're defining the type of team, and we'll call that a football league equals new league, and we'll say that's the AFL, Australian Football League, AFL. And what we need to do is to go back and copy those variables for those various teams. So I'm just going to tab back over to that other class from our main method, and I'm going to add some of these. And we had so what I'll do is I'll just copy a heap of these, and then I'll actually just remove what we need to. Paste that in. So we've got the Adelaide Crows, and then we also had these other teams here, Melbourne, and we had Hawthorn and Fremantle. So we actually had, in this case now, we've actually got 4 teams. Let's actually go ahead now and actually add those. So it would be football league.add, Adelaide Crows, football league.add, Melbourne, football league.add, Hawthorn, and football league.add, Fremantle like so. And that's actually all working perfectly as you'd expect. But also let's go back and just copy from the other project, the baseball league, which I probably shouldn't have deleted that. So let's just copy that one. And we'll come up here and put that in there as our definition. So what we need to do is copy the baseball player class as well. So I'm just going to come back here, baseball player, right click, copy, go back to our generics challenge project, right click and paste, baseball player. And obviously that now, if we go back to league, should fix that error. So if we go back to main, I should say, we've now got that. So if we actually now try and add it, so football league.add, baseball player team, we actually get a compile time error, as we should now, because obviously the baseball player cannot be applied to league because we've actually said this particular league, we're using generics. Yes, it's a team, but this is the type, football player only. So that's good, that's actually working. And now to actually print out the results, we can do football league.show league table. Now if we do that by default, we should run that. I haven't got any results in there at the moment. So everything's on 0. So what we need to do is actually, again, copy through results. We'll copy these 3 results, paste those in. Let's put them in there, some results. And if we actually run it again, we've actually got things in the right order. We've got Adelaide Crows on 4 points, Hawthorn 2, Melbourne 0, and Fremantle 0. So that's actually good. So that's the basic challenge. But what I want to do is, before I finish, I want to just talk a little bit more about, go through the warnings about using raw types, because it's really important to actually understand why we actually don't want to do that. And probably a bit of code here will actually help. Because again, the raw types are actually allowed in order to allow the legacy code, that's code prior to Java 1.5, or code written before the generics was introduced to Java, to allow that to actually work. But you can't rely on the compiler giving an error when you use those raw types. You'll actually get a warning. IntelliJ will also warn you, but the code will compile. So again, just as a confirmation, I'm going to paste a bit of code in here. And I'll change that to Adelaide. And we need a couple of players. We'll go back to Beckham and Pat. We'll copy those 2. Like so. And we probably should have done this at the start. Copy the soccer class as well. Copy that. Paste it over here into this package. Paste. Okay, go back to main again. So again, in this example, this code will actually run. It's an unchecked warning. So if I actually close down the run window, you can probably see this a little bit easier. IntelliJ is going to be telling you that this is an unchecked call. So we're not actually defining the types as we have up here. So the code will still actually run, but we'll get those warnings. And we notice how we can actually add literally whatever we want. We're adding Adelaide Crows baseball team and raw team to this league, and it's quite happily allowing us to do that, even though, of course, they're all parts of different types of sports, and you wouldn't normally want to do that. And this is all because we're using the raw types, not the generics. So that's should hopefully really sort of hitting home to you that you want to be using these generics whenever you can, because it makes your code cleaner, less likely to have crashes, and easier to debug, essentially. because the errors that you're getting are going to be there at compile time and not obviously when the code's in production and you're trying to fix these weird bugs. So again, the real issue is the line something like this where we're actually just not specifying a type for the team. So without going into it any further, we could actually mitigate some of these problems to at least prevent the raw league declaration from compiling. We could actually go back into our league class where it's got t extends player. We could put something like u extends player, t extends team, something along those lines. If we go back and actually have a look at main, it's now requiring 2 parameters, and we could actually put league. We could actually force it there by putting something like football player, comma team. That would be one way of actually solving the problem, because it's now actually coming up and saying that there's a problem with the baseball team. But it's still not an ideal solution, and for that reason I would actually recommend you do as I've done in the challenge, and you actually come back and actually do something like we did there to actually make it far easier to actually work with. So that's it with generics. I hope you've got a lot out of this section, and we'll see you in the next section when we're continuing on our journey into Java.